All right, so the first box we're going to fill in just something called the Arc Addition Postulate. And the Arc Addition Postulate is like any of the addition postulates we've learned throughout geometry all year. So first we started with the segment addition and postulate, which basically said if you have this much of a segment plus this much of a segment, you add them together and it equals the whole thing. And then we had the angle addition postulate, which said if you have this angle and this angle, you add them together and you get the whole thing. So guess what happens with the arc addition postulate? You have a circle. You take the first arc. So we'll call these 3 points on the circle A, B, C. So we'll take the first arc, which is AB, and we'll add the second arc, which is BC, and it's going to be equal to this plus this. So it's going to be equal to arc ABC, all of it. Okay? And so if one of them was 20 degrees and the other one was 30 degrees, you would say that together they were 50 degrees. Okay? All right, so let's look at an example. Example number 1. Bless you. On the wrong page. We're going to have a circle. It's going to be we'll call it circle J. And it's going to come up to here to F, over here to G, over here to H, and over here to K. All right. There's also another point over here. We'll call it L. And so each of these is going to be different types of grass. So this is a lawn care company, and they're going to be planting some yards with the different kinds of grass. So this one is a grass called, and I don't even know how to pronounce this, zoysia, and that's 20%. This one right here I've heard of before. It's called fescue. It's pretty common, 8%. This one right here is very common, what most people have, Bermuda, and that's 7%. And over here we've got centipede, and it's 65%. Okay? Because these are in percents and not in degrees, a full circle should add up to how much percent? 100%. Versus the degrees in the circle is not 100 degrees. It's how many degrees? 360. Okay? So we're going to be asked to find the measure of arc KLF. All right, so let's figure out where K is at. So here's, I'm going to use a different color. All right, so here's K, and then here's L, and then here's F. So from here all the way around to here. So if we look and we see that it's 65%, we can take 65%, which is, if we change that to a decimal, is equal to what? 0.65. So you just want to take the decimal point from here, move it 2 places to the left, and you're going to get 0.65. And then we're going to multiply that by 360. So 0.65 times 360. Take your calculator and go 0.65. If you want to type the 0, you can. Times 360. And I got that the measure of angle or arc KLF is 234 what? Degrees. Make sure you don't write percent. Okay? Any questions on example number 1 there? All right, example number 2. We're going to have another circle, so hopefully we get good at drawing circles. Okay, that one's pretty good. So this is going to be circle F, and we have one radius coming over here to B, another radius coming over here to A, a radius coming over here to E, and another radius coming here to D, and one coming here to C. And then we're going to have, I drew this wrong, sorry. This should be C and D should be in here. Let me wipe that out. That's what happens when you get sloppy. Sorry. All better. All right. Now let's fill in some measurements. We've got AFE is 97.4 degrees, and EFD in here is 52 degrees. So we're going to be asked to find the measure of arc BD. All right, so BD, let me use a different color so we can focus in on BD. So here's B, here's D way over here. We want to get this total of the arc. However, we only have this much and this much. The reason I had to fix this line is because one thing you want to notice is this line is what? Is straight across. Okay, so if this is straight across, that's how many degrees? 180. So we want to take the 180, subtract the 2 that we know. We know the 97.4. We know the 52 right there. And if you punch that into your calculator, that's going to leave you with 30.6 degrees. Announcements? Okay. 6 degrees for this angle right in here. 30.6 degrees. The other one we know, and we haven't seen this in a while, is this line right here and this line right here creates what we call vertical angles. And vertical angles are congruent, right? So if this one's 97.4, this one is also 97.4. So we can take that 97.4 and add it to the 30.6. And our arc BD is 30.6 plus 97.4. We are at 128 degrees. Okay? So this is something to look for. Vertical angles. If you see vertical angles where they make that X, then the two angles opposite each other are going to be congruent. Any questions on example number 2? My drawing was horrible. Sorry, I apologize. Okay? I'm going to move this up. All right. The next thing we're going to look at is on your sheet, on this side, there's a box on the side that says distance or length. There's a box that has Theorem 11-2-2. So I'm going to read through these theorems. We're not going to write the whole thing on there, but if for some reason you need all the words, you can refer to the sheet. So the first one says, in a circle or congruent circles, the first one is that the congruent central angles have congruent chords. Okay? So right here on circle A, this little congruent mark and this little congruent mark show that those two central angles are congruent. Therefore, this chord and this chord connecting those arc points are going to be congruent. We're going to draw that on your paper in just a second. The second one says that congruent chords have congruent arcs. So if the chords are congruent, then the arcs are going to be congruent as well. All three of these are related. That's why they're kind of grouped together. And then the third one says that congruent arcs have congruent central angles. So then if the arcs are congruent, then the angles are congruent, which is basically the converse of what the first one said. Okay? So in your little theorem box, we're going to draw these three guys. Okay? The first one is a circle. We're going to call it circle A. And we're going to draw in two congruent angles. How do we know they're congruent? Well, we're going to put this little congruent arc mark. Okay? So this one is going to intercept at E and D, and this one is going to intercept at B and C. This theorem says that if angle EAD is congruent to angle BAC, then this piece, ED, is congruent to this piece right here, BC. Okay? Then the next one says that if those two pieces, so ED is congruent to BC, then arc DE is congruent to arc BC. So this is the first one, this is the second one, and then the third one says that if ED is congruent to BC, then the angles are congruent. So angle DAE is congruent to angle BAC. They all kind of lead to each other. So this one leads to this one leads to this one, and then this one leads back up to that one. So if one of those three things is true, then all three of them are true. The angles are congruent, therefore the chords are congruent, therefore the arcs are congruent, therefore the angles are congruent, therefore the chords are congruent, therefore the arcs are congruent. If one of the pairs is congruent, then all three pairs are congruent to each other. Keeps going in a circle. All right. So how are we going to apply this? That would be example number 3. All right, if you still need this, it's on this sheet right here. Okay, so example number 3, we're going to draw a circle. And on this circle, we're going to draw a chord over here and a chord over here. This chord is TV, and this chord down here is SW. These two chords are congruent. So that's the first statement we're going to say, is that TV is congruent to WS. Awesome. So we're going to find the measure of arc WS. All right, so we need some measurements. This arc over here, arc TV, is going to be 9n minus 11, and this arc over here is going to be 7n plus 11. Okay, now they're telling us that the chords are congruent, which is semi-helpful in getting the arcs congruent, because of the theorem that we just said, that if the central angles are congruent, then the chords are congruent. If the chords are congruent, then the arcs are congruent. So in this case, if the chords are congruent, which they are, they told us and we marked them, then their arcs are congruent.